any equipment which uses electric power, so naturally it will tend to have electrical problems or malfunctions. In the US statistics, 50% of the electrical fires caused because of the distribution or lighting equipment which ignited the fire. The remaining all like household equipments like dryer 6%, fan 6%, AC equipment 4%, water heater 3%, ranges 3%, something like that. These electrical fire hazards or electrical shocks, why it is happening? It is not happening. It is due to the built-in critical problem which is already available in the houses. Say the power sockets, lighting, it's not properly earthed. The earth electrodes are not properly provided, or your mains is not provided with the residual current deduction devices, the so-called earth leakage circuit breakers, and wet and toilet area, any equipment is there, not protected by residual current devices, and of course there is a wear and tear. Any electrical equipment used by the time, after some time, they tend to fail, and the consequent shocks also. The other problem is the human created problem. So the one is already available in the house, the other one is the human created problem. Like the outlets are not properly available in the house. Maybe the house requires in modern days 4 or 5 sockets, they may have 1 or 2 sockets. So they tend to use the flexible cables, so by which they extend to the utility nearby place. So these flexibles, they will move through the carpets, and they may tend to use the higher capacity machines beyond the capacity of its flexible. So this will cause a major fire hazard. Of course, the related electric shock. The other one is the multi-sockets. They don't know what is the capacity of the multi-socket can take the power. Suppose you may use ironing machines, and simultaneously you can use some other high-powered machines. So this also will have a major fire consequences. The major part is everybody thinks they know electrical, so they tend to modify their installations, which they are not aware what they are doing, which is a major source of fire hazard. So moving to the electric shock. The electric shock. Now let me define about our human body. The consequences of electric shock may be a transitory, discomfort or death, depending on the severity, timing, and the duration of the shock. The major functions of the electrical body is controlled by electrical signals, and this electric shock which severely affects the body. So the internal human body is like a salt solution. It will conduct electricity. The current rating or the body resistance, it depends on the tissue, orientation, and etc. The human skin will have a very high resistance, which is of course it is the first one which will have a contact with the electricity. The dry skin may have several thousand ohms, but wet skin will be much less. When it comes to the electrical shock, so when you put a hand, the other hand, if these two are subjected to electric shock, the current pass through the heart as well as the muscles which is operating the breathing system, so which is going to be very severe. Similarly, the one hand and leg, this also will have a severe consequences. Now let me talk about the magnitude of the current. The magnitude of current depends upon, as I already said, the resistance of the body and the conditions also. Higher is the resistance, and lesser is the current. Higher is the voltage, higher is the current. Now, if we take 0 to 0.4 milliamps, we can continuously sustain. But let us say we will move to the next one. So there will be a physical discomfort happens, like 20 milliamps you can withstand up to 500 milliseconds. 30 milliamps you can withstand up to 300 milliseconds. Like that. when it goes to higher, then there will be a burn or fibrillation of heart and so many things will happen. Now let us see how we are going to protect it. That is the reason in our OIN regulation it says provide 30 milliamps for the house's socket. This is the main reason. So when 30 milliamps passes, if it can trip within 400 milliseconds, the human will be safe. There is no damage to the human body, or you will not have any physiological problem. But this is where the human handles, where we will go for a 30 milliamps. When it comes to the items which we are not going to touch, if we have 30 milliamps, there will be a nuisance stream. So we will go for a 300 milliamps. At the same time, it will take care of the tripping and other things also. So everybody should know at least something about RCD. Any further information is required, they may be contacted. So we have to separate. When bedroom is there, we have to give separate ELCD. When kitchen is there, there should be a separate ELCD, so that discrimination of faults can be easily identified.